Hello, my name is Nur Aleyssa Najihah Binti Ahmad Johaniff. My metric number is 24303854 from experiment group T3B. My partner for this experiment is Muhammad Irfan Hakim bin Hafiz. This video is presented for the Viva Voce of the 1GP2 projectile motion experiment. In this experiment, we study the projectile motion of a steel ball using P-wheel's projectile motion experiment set. The steel ball is launched by a spring at different initial speed and at different angles of projection to the horizontal. The main objective of this experiment is to investigate the relationship between the range, maximum height of projection, angle of projection, and initial speed of the projectile. The experiment consists of two parts. Part A investigates the variation of range and height with projection angle at different initial speed. Part B studies the relationship between the maximum range and the initial speed at a fixed angle of 55 degrees. Part B studies the relationship between the maximum range and the initial speed at a fixed angle of 45 degrees. For question A, the best angle of projection to start the experiment is 45 degrees. From theoretical projectile motion, the range of a projectile is given by using this formula. The range is maximum when the value of sine 2 theta is maximum, which occurs when 2 theta equal to 90, giving theta equal to 45 degrees. Therefore, a projection angle of 45 degrees produces the maximum horizontal range, assuming a resistance is negligible. For question B, the maximum height of projection can be measured accurately by placing a vertical scale parallel to the plane of a projection. The highest point reached by the projectile can be observed and measured directly using the scale. In addition, the maximum height can also be calculated theoretically using the equation here, which allow comparison between experimental and theoretical values and help to reduce measurement uncertainty. For question C, the time taken for the projectile to reach its maximum height can be determined using the vertical component of motion. At the maximum height, the vertical velocity of the projectile becomes 0 using the equation here. The times to reach maximum height is here. This method provides an accurate way to determine the time taken for the projectile to reach its highest point. For question D, from a theoretical physics point of view, the material of the balls does not affect the range of height of projection. This is because the equation of projectile motion depends only on the initial speed, angle of projection, and gravitational acceleration, and do not include mass or material as variables. Therefore, under ideal conditions without air resistance, all objects follow the same projectile path. For question E, although the material does not affect projectile motion theoretically, significant discrepancies are observed in real experiments. These discrepancies are mainly due to air resistance, which is not considered in ideal projectile motion equation. A wooden ball experiences a greater effect of air resistance due to its lower density and larger effective surface area compared to a steel ball. As a result, the wooden ball travels a shorter range and reaches a lower maximum height than the steel ball. So, in conclusion, this experiment demonstrates the principle of projectile motion and confirm the theoretical relationship between range, height, angles of projection, and initial speed. The difference between experimental and theoretical results highlight the effect of non-ideal factors such as air resistance in practical experiments. Thank you.